Hello guys, today we will see the Leetcode problem number 3047. Find the largest area of square inside two rectangles. Okay. Now there exist n rectangles in a 2D plane with edges parallel to the x and y axis. You are given two 2D integer arrays bottom left and top right, where the bottom left of I denotes the bottom left coordinates of that ith rectangle, and the top right of ith represent the top right coordinates of that particular ith rectangle, represent the bottom left and the top right coordinates of the ith rectangle. Okay, you need to find the maximum area of the square that can fit inside the intersecting region of at least two rectangles. So we have to find if any of the square can be fit into any of the overlapping regions. Okay, so we have to fit the we have to fit the square inside that overlapping region. Okay, we do not have to fit in the rectangle, we have to fit the square on that overlapping region. Okay, square, take care of this. Okay, the maximum area of square we have to fit in. Okay, after this, okay, so to solve this, let's see what happens. Okay, let's see if we have these two rectangles and in another condition we have these two rectangles. Okay, when they are overlapping and when they are not overlapping. Okay, so to get the overlapping regions, okay, so we have to find out here the overlapping region between all the possible rectangles, combination of that all possible rectangles. So for combination we have to apply all the we have to apply the n square loop for all the possible squares. So it can be possible because the n value is 10 to the power 3 only, and the total time complexity after applying the n square loop can be 10 to the power 3 square. So it will result into 10 to the power 6, and this can also be possible. Okay, so that's why we will apply the n square loop. Okay, n square. Now let's see if in condition 1, if we have, okay, in condition 1, let's see, okay, let's see, let's discuss the condition 2 first. Okay, because here we have got the overlappings. Okay, so to find out the overlapping region, the length and breadth, okay, it can be length and breadth. So the length and breadth can be, this can be 3, this can be 2, or this can be either can be 2, either can be 3, or they can also same also. Okay, so that's why we have to figure out the length and the breadth of the overlapping region. Okay, how we will find out? So firstly, if they are overlapping, so we will figure out the minimum from this two. Okay, the x, the minimum of x coordinates from these two vertical lines. Okay, minus, okay, just take this as a 1, this as a 2, so the maximum from this and this. Okay, the maximum from both of them will be 2, then this. Okay, and then the minimum from this and this. Okay, minimum from this and this, so this can be 4, this can be 6, so it can be 4 minus of 2. Okay, 4 minus of 2, we will get this length. Okay, by getting 4 minus of 2, we will get this length. Okay, this will be 4 minus of 2 will be 2. Okay, so this will be 2. After this, we will take the minimum from this and minimum from this, sorry, maximum from this and maximum from this. So let's take this as a 1, this as a 2, this as a 5u, and this as a 7. Okay, so in this case, this is 2, and this whole distance can be calculated. This now whole distance we have to calculate. Okay, so for this we can find out the maximum from this and maximum from this will be 2. Okay, and then minimum from 5 and minimum from 7. So our total distance from, okay, total this distance will be 7 minus of 5. Okay, 5 minus of 2 will be 3. Okay, now we have, now in this case we have this this as this length, this breadth, or let's say this as a length. Okay, and this as a breadth. So length is equal to 2 and breadth is equal to 3. Breadth is equal to 3. So now how much area, how much square, okay, we can fit in. Okay, the maximum square we can fit inside it will be the 2 by 2, because 3 by 3 cannot be possible here. So that's why we will insert the 2 by 2 square inside this container. Okay, inside this overlapping region. So this overlapping region contains the 2 by 2 of the square. This 2 by 2 region can be overlapped there. Okay, now if there are non-overlapping regions, so how our code will work? Okay, after taking this, let's discuss with this code only. Firstly we will have the we are storing our answer, and then we have initialized, and double for loop we are applying for every combination of rectangles. Okay, so every rectangle will be combined with the every other rectangle, and that's why our time complexity will be the n square. Okay, then we are storing this variables into x1 and x3 format, because of to get it more suitable for understanding. And this is the best practices you can do to make it more simple to understand, or to make it more simple to solve. Then all the logic is behind this one line only. The temp is equal to the temp is having the minimum. Okay, let's forget about this minimum thing. Okay, let's forget about this minimum. Okay, only this one and this one. Okay, so this is the your length, this is your breadth. Okay, of the overlapping region. Okay, you can find it that separately also, but I have done all the calculation in one variable only, in one line only. So the length is minimum from x2 and x4 and x1 and x3 maximum. So how so you will think that when there are no overlapping regions, so it may fail. Okay, so that's why we have applied this temp is greater than 0, because when we have the non-overlapping regions between any of the two rectangles, so it will give us the negative answer simply. Now let's say this, okay, so minimum from this and this we will get this one. Okay, then maximum from this and maximum from this we will get this. So that's why our region can form this and this. Okay, after that maximum from this and maximum from this. Okay, maximum of this and maximum of this, and then minimum of this and minimum of this. Okay, so this minus of this but this will be okay. So let's say this is a 2, this x is equal to 5 here, okay, and there x is equal to 4, here x is equal to 2. But now we are doing what we are doing, that if they are like overlapping each other, okay, if they overlap each other, so we can make 5 we can make 4 sorry, the 4 can be greater than x is equal to 5, okay. So this line should be ahead of this line, okay, then only it can be overlap. But now we have to subtract this 5, okay, and this is the 4, so we have to subtract 4 minus of 5, so that's why it will give -1. So in this region the -1, okay, now this to this can be positive, but now this to this, okay, so this region is negative now. So in our temp variable, when we think about the minimum from our length and the breadth, so it will return just take the length as is equal to 2 and the breadth as -1, so it will take the minimum of them, okay. So if the temp is less than equal to 0, so answer will be 0 or nothing. So that's why then answer will not get changed. So means it clearly says that there is no overlapping region, okay. And if the temp is greater than equal to 0, so the answer will calculate the area of the square which can be overlapped on that overlapping region. So this is our overall approach, and if you are getting any of the doubts, please comment down below. I will be clearing your doubts surely. Thank you.